Here we're going to talk about the basics on getting started with trigonometric ratios. Okay. Well, in order to get started with trigonometric ratio, you have to start all the way at the beginning, which is with a triangle. And this is a very specific triangle. This is a right triangle. And if you remember, we designate your right triangle by having this little box here in the corner. And usually it's in the corner of your what appears to be the 90-degree angle. Now, for the purposes of what we're doing here, we are going to identify this angle down here as being our theta angle. And the reason we're going to identify that is because we have to be able to label our triangle to reference trigonometric ratios. So for example, this theta angle here, I'm going to label with A. And so when I'm talking about this particular angle, this length right across from it is considered or called the opposite. Okay, now with that, we usually like to abbreviate as OPP. Now let's say that this angle up here is angle B. Well, when we are talking again about your reference angle, or the theta, so this is the angle of the triangle we're looking at, this side length down here next to it is going to be called adjacent, of which we label usually ADJ. Last but not least, we have our right angle here, which we would label as angle C, and then we have our long side here, which is the hypotenuse, and the hypotenuse we usually label as HYP. Okay. Now with that, we have to know how these different ideas occur in terms of your trig functions. So when we talk about the trig functions, we have what are called the major three. So your sine, your cosine, your tangent, and your minor three, your cosecant, your secant, and your cotangent. So let's go ahead and start with the top. So we have sine. So we need to look at what actually is sine. So when we look at it, we choose an angle that we're starting with. So we're going to use this theta right here. And when we designate sine, the definition for sine is going to be opposite over hypotenuse. So the definition again is going to be opposite over hypotenuse. Cosine then is going to be the adjacent over your hypotenuse. So we would label that one as ADJ over your hypotenuse. So since I've already used opposite over hypotenuse and adjacent over hypotenuse, that means the only combination that's left is opposite over adjacent, which is what we call our tangent. So this one is opposite over adjacent. Now we have the minor three, and so the minor three are essentially taking one of your big three and flipping the reciprocal. So when we have cosecant, that is the opposite or the reciprocal of sine. So in this case, we would label it as hypotenuse over opposite. It's the reciprocal, so you're going to flip it on its head. Secant is the reciprocal for cosine, so this is going to be hypotenuse over adjacent. And then the last one that we have is the cotangent. So the cotangent again is the reciprocal of tangent, so this is going to be adjacent over opposite. Now that being said, we do have three other ways that we can look at what are considered to be the minor three trig functions, or the reciprocal functions. And those have to do with what it looks like in terms of the trig itself. So cosecant is the same as 1 over the sine of theta. Cotangent is going to be the same as 1 over the tangent of theta. And that means secant is the same as 1 over the cosine of theta. Alright, now there's a few other things that we have to keep in mind. First and foremost, we need to recall what that Pythagoreans Theorem is. So if you remember Pythagoreans Theorem, a squared plus b squared equals c squared. Now in trig, we use Pythagoreans Theorem quite a bit in order to help find side lengths of triangles, and that being the fact that sometimes you're going to have a missing side. Now in this case, I've given you all of the sides. Okay? And so here, what we need to do is you need to find all 6 of your trig functions using your specified angle. So we've given the angle a designation. In this case it's beta. And so we're going to use this as the reference in order to find your trig functions. So first and foremost, we have our 3 major functions. So we have sine of beta. Then we're going to have the cosine of beta. And last we're going to have the tangent of beta. So first and foremost, we need to remember sine was opposite over hypotenuse, and the hypotenuse is always going to be the longest side. So I'm going to look at my beta and I want to go opposite. So in this case, my opposite is going to be this 3 square roots of 3. So opposite is going to be 3 square roots of 3. And then my hypotenuse is 6. Now, the biggest thing that you always have to remember is you must reduce as far as you can. So in this case, we know that 3 and 6 are going to reduce. 3 goes away. It's going to leave 2 behind. So technically, my sine of beta is going to be the square root of 3 over 2. Now, we also have to do cosine. So if you remember, cosine is going to be adjacent over hypotenuse. Adjacent is the side that is right next to the angle you're referencing. So in this case, it's 3. So here we're going to look at 3 over 6. Again, we're going to reduce, so this becomes 1/2. Last, we have tangent, and tangent is again opposite over adjacent. So opposite is going to give us that 3 square roots of 3, and the adjacent is going to give us over 3. Again, when we reduce, we end up with the square root of 3. Now those are just simply the major 3 trig functions. Well, we also have the minor 3 trig functions. So we have to remember when working with your trig functions that we also have your cosecant, so the cosecant of beta. We have the secant of that beta, and we have the cotangent of that beta. So first and foremost, there's a few things that we have to remember. Okay, one is when we're talking about cosecant, we're talking about 1 over this sine, and in this case it would be of beta. The other thing that we need to remember is that if sine was opposite over hypotenuse, then cosecant is going to be your hypotenuse over opposite. So whether you want to think of it as 1 over the sine or you want to think of the actual definition is completely up to you, but we still have to put the values in either way. So if we're looking at using the definition of hypotenuse over opposite. Then in this case, my hypotenuse was 6. My opposite was 3 square roots of 3. Now in reducing this, the first thing that you would do is we would reduce the 6 and the 3. So this goes away, leaves a 2 on top, which means that what we actually get here was 2 over the square root of 3. Now one thing that most students forget is we now have to rationalize the denominator. So this means you cannot leave the radical down there. So in order to rationalize, we're going to have to multiply the top and the bottom by the square root of 3. We're going to multiply straight across the top and straight across the bottom, and we are going to end up with 2 square roots of 3 over 3. Since there's nothing else for me to simplify, this is my cosecant of beta. Now I need to do the same thing with my secant. So if I remember secant, this is going to be the same as 1 over the cosine of beta. Now, with my cosecant, since I went ahead and used my definition here of hypotenuse over opposite, I'm going to show you how to use the other definition using the major. So this would be 1 over the cosine. So what this would mean is that we were going to do 1 over, and then if you notice that cosine of beta was 1/2. So this would be 1 over my 1/2. My fraction rules say that I keep the top, change to multiplication, and flip the reciprocal of the bottom. So this becomes 1 times 2 over 1, which ends up with 2. So my secant of beta is 2. Now let me show you this method one more time using my cotangent. So here this is going to be the same as 1 over the tangent of beta. And in our case, if you remember, the tangent was the square root of 3. So this is going to be the same as 1 over the square root of 3. We again have to rationalize. So rationalizing says I'm going to multiply the top and the bottom by the square root of 3. Straight across the top, straight across the bottom leaves me with the square root of 3 over 3 as my cotangent. Okay. So that is one example of being able to list all 6 trig functions for a specific triangle given the information provided. Now, what happens if we are given a function value of an acute angle and you're asked to find the other 5? So here I'm telling you what your value is. Well, in order to do this, the first thing that I would do is I would actually draw myself out a triangle. So I would go ahead and I would draw myself a triangle, and you can draw it and make it look however you would like. And then you need to identify one of your angles as your angle to work with. So I'm going to identify my top one as my theta. And so now I need to look at this decimal right here has a fraction. So one of the things that I know is I know that 0.7 is actually the same thing as 7 over 10. The other thing I know is that that was cosine. And I know cosine is adjacent over hypotenuse. So this means when I'm looking at it, I have adjacent over my hypotenuse. And so I can input those values. Adjacent is the value next to it, so this would be a 7 on this side. Hypotenuse is the long side. This would be a 10. Now, we don't know this third side, and this is where Pythagoreans Theorem comes into play. So the first thing that we would do is we would have to solve a squared plus b squared equals c squared. So here I've got x squared plus my 7 squared has to equal my 10 squared. So I have that x squared plus 49 is equal to 100. So x is equal to the square root of 51. So that's what would go right here, that this would be the square root of 51. Once you've figured out this missing side, now you have everything you need in order to set yourself up. So we need to find the other 5 functions. So the first one that we have is the sine of theta is going to be opposite over hypotenuse. So my theta is right here at the top, so the opposite is going to be the square root of 51 over my hypotenuse, which is 10. I then have my tangent. So tangent is going to be opposite, so the square root of 51 over the adjacent, which is 7. And now we need to do cosecant, which is the same as 1 over the sine, which in this case is going to take our sine and we're going to flip it on its head. So here this becomes 10 over the square root of 51. When you rationalize, this is going to change and instead is going to give you 10 square roots of 51 over 51. We need to do the secant, which is the same as 1 over the cosine. And in this case, my cosine was going to be 10 or 7 over 10. So when we flip it, this ends up being 10 over 7. And then the last one we have is the cotangent. And in this case, that's 1 over the tangent. My tangent here was square root of 51 over 7. So we're going to flip it. This becomes 7 over the square root of 51. After you rationalize, we end up with 7 square roots of 51 all over 51. And so there is a second example of being able to find the missing information given the information provided. So now let's look at one last example. So in this case, we are told that we have the secant of theta is going to be the square root of 17. So let's see what we can do with the secant here. So the first thing that I would do is, again, I would start with drawing a triangle and identify your theta point. Okay, so here I'll put it in the top. And then we need to figure out what we actually have here. So secant, if you remember, is going to be the hypotenuse over adjacent. Now the other thing that we need to remember is that any whole number you have is essentially over 1. So when we're looking at inputting values, my hypotenuse is going to be the square root of 17. My adjacent is going to be a 1, and the missing piece is x. So we have to solve for it. In order to solve for it in this case, again, remember we're going to use that a squared plus b squared gives you c squared. So here I have x squared plus 1 squared is equal to the square root of 17 squared. So here I get x squared plus 1 equals 17. So I have that x squared equals 16, so x equals 4. Now notice I'm not including the plus or minus because when we're talking about a side length, you can only have a positive distance. So here this is going to be 4. Now once you know your side lengths, you just simply have to fill in the missing pieces. So here the first one we're going to have is we're going to have sine of theta. Sine, again, is opposite over hypotenuse, so this is 4 over the square root of 17. Once you rationalize, we end up with 4 square roots of 17 all over 17. Now I need to do cosine. Cosine is adjacent over hypotenuse. So in this case, we're going to have 1 over the square root of 17, which after rationalizing is the square root of 17 over 17. Now we need to do tangent. So my tangent is opposite over adjacent, so this becomes 4 over 1. However, most of us would just simply write that as 4. Now the last ones we have is we have cosecant. So cosecant is the same as 1 over the sine of theta. My sine of theta is 4 square roots of 17 over 17, but if you remember the way it started, it'll make your life really easy because we're going to flip that reciprocal. So this becomes the square root of 17 over 4. Now the only other one we have is cotangent of theta, which again is the same as 1 over the tangent. So in this case my tangent was 4, so flip the reciprocal, we get 1/4. So that is everything that you would need to know to get started working with your trig functions. So if you have any questions, please let me know. If you feel like you need more examples, or if I made a mistake somewhere, let me know that too. Otherwise, sit back, relax, and have a good night.